Hello, I'm Bob Montgomery. I'm a weed management TDR. I work in the Tennessee, Arkansas, Boot Hill, and Missouri area, and we're here today in Keiser, Arkansas. We're looking at a test that we're working with Dr. Jason Norsworthy here at the Keiser station. We have 5 of these tests around the Mid-South where we're working with our academic cooperators. We're trying to get a handle on applying dicamba technology in soybeans, and one of the things we want to investigate and understand well is how this product moves outside the target area where we're trying to use it. You can see this plot here was sprayed directly with one of our new premix products that is premixed at a rate that would be equal to about 30 ounces of Roundup and 16 ounces of a dicamba-like product. Some of the things we're looking at in these soybeans that you can see around the outside of this plot, and that's basically what we're looking at. We're looking at it on the upwind side for any potential volatility, and we're looking at it on the downwind side, which you can probably see behind me, for any potential off-target movement that there may be with what we call drift. Mostly in the business I'm in, that's what we call it. But we're measuring several symptoms that occur, or several things that happen. One of the things that we measure is leaf injury, leaf damage. Some of us in the business with these growth regulator herbicides call this epinasty. You can see it on these soybeans here. It's kind of a wrinkling type of symptom. So we're measuring this at the point closest to the plot, and we measure it as it goes away and as it moves away from the plot, because we need to understand how it looks and how far it's going to move when we try to use the product. Another variable that we need to understand and measure is the height of the soybeans. You can see that there's some variability in height down the plume where the off-target movement went. And you can tell that the wind came from this direction and the herbicide moved off in this direction the day we sprayed it. The day we sprayed it, the temperature was relatively high in the 90s, and we tried to catch the wind. It was kind of variable in the 4 to 7 miles per hour range when we made the application, because we think that's in the range where farmers will try to get product in the field. As we get above 10 miles per hour, sometimes it's kind of questionable about keeping any herbicide in the field. So we felt like we were in a range where a lot of farmers tried to make spray application. In addition to measuring these leaf symptoms and the height on these soybeans as we move away from the spray area, as these soybeans mature, we will lay this off into individual plots, and we will harvest these individual plots in the same way. So we'll have a measure of the leaf symptoms, the height, and also we'll have yield as we move away from this plot. So this will help us understand what the soybean symptomology is, how the product affects height, and ultimately what we want to know is what the effect on yield is, if any. I would say we have 2 treatments in this study, and we have this replicated 3 times, and the 2 treatments are 2 different nozzle types. One of them is an AI nozzle, and one of them, the AI nozzle is a coarse nozzle. And the other nozzle that we're testing is a TTI nozzle, and it's an ultra coarse nozzle. If you look behind me, some of these symptoms these soybeans had recovered, and you could see symptomology a little further than you could see today at about 21 days after the study, and today's about 35 days after the study. But this was one of the treatments where we used the TTI nozzle. And we were fairly happy to see the movement of the product. It seemed to be within a range that we could contain the product in the field where we were trying to make the application with a reasonable boundary away from what might be a crop that would be sensitive to the herbicide.